Okay, so now we're going to talk about classification. So classification is another machine learning algorithm, and it's very similar to regression, but instead we are predicting labels. So again, junk mail is one particular way of using classification. So in that case, we're determining if something is spam or it isn't spam. And again, it's a type of supervised learning algorithm, and supervised meaning that the data is fed uh, that is previously labeled, and it has the important features and attributes already separated into distinct categories. So one example of this was, again, when we took a look at the recession and not recession data. And again, that is a type of classification that you're using. You're classifying economic conditions as a recession or not a recession based on data that's already been pre-labeled. And another way of looking at this is you can use the k nearest neighbors. That's another model that's used frequently in classification. So basically what it does is it checks the distance from some test example to the known values of some training example. So again, that's another type of supervised learning. We also have decision trees. So decision trees are a type of ensemble method, and it breaks down a data set into smaller subsets where different sorting criteria is used to divide the data set down to a root example where a classification is eventually made. And then finally, we have naive Bayes, and that basically determines the probability that an example belongs to a particular class. Principal component analysis. Principal component analysis is one of the most powerful factor shrinkage methods commonly used in machine learning. Lots of advantages in terms of factor shrinkage, orthogonal transformation, speeding up the fitting of your models. And essentially, when I say factor shrinkage, it's useful for big data particularly. So let's say you have a data set that has thousands of rows, or excuse me, millions of rows, thousands of columns. And what you want to do is reduce the number of columns down to the orthogonal roots and still maintain the explanatory power of this data. So you would use principal component analysis. Why? Because when you shrink down the factors, you're maintaining the orthogonal roots, meaning that there's no correlation between those components, which makes it really powerful. So you don't have to worry about multi-collinearity. And at the same time, because you're using fewer factors, or you're reducing the dimension of your x's, it speeds up the fitting of the model. So you can save time when you're computing. You can use a different type of instance. It's just much more efficient. Natural language processing is next. We'll talk about that right after this break.